Okay, thank you. Cool. Hi everyone, this is Sanaz, Rasti. Um, and here I'm presenting the All-Tech topic modeling incorporating a topic model selection strategy. This research was conducted under Irish Research Council, funded by this funding body, and the project called Koalas Platforming Harm. So we are looking at the old tech, and the old tech are the social media platforms and internet service providers, which they have become popular as among the alt-right and far-right and extremists in social media platforms. So these platforms usually they don't have that strict content moderations. And the example of these platforms is Getter, Triller, Parler, Gab, Truth, and well, Telegram is a popular social media platform which has become also popular among these extremists. And we are looking at data from Telegram, which was collected from an old tech channel. The old tech channel that we are looking at is Computing Forever, and this is one of the popular, actually, old tech channels among the Irish channels. So, and the posts are created by a celebrity. This is kind of like a social media celebrity as well, and he considers himself to have a critical mind. So he usually writes about like technology and social commentaries, also criticism of social justice, political correctness, and hyper-consumerism. So we collected the data from two distinct years of 2021 and 2023, and the data has over like 10,000 documents, and also 100,000 documents from the next year, next corpus. So as well as this data set, we collected some labeled data set. We had 3 other different data sets that they were labeled, and used these as like for doing the quantitative research on our algorithm. And these data set, the labeled ones are Amazon reviews and Yelp reviews and computer science abstracts. So the length of corpus as well is mentioned here in this table. Then for the methods and evaluation, so as for any NLP project, we started by doing the data pre-processing. And for the data pre-processing, we converted all the text into lowercase and the Unicode format, and then punctuations and the emoji patterns were removed from the corpus. List of English stop words, as well as specific stop words for the alt tech channels, they were removed from the corpus as well. Then the empty document strings, finally, they were removed from the corpus. And finally, when we had the count of corpus tokens for overall, we could say that the count of corpus was reduced by 56%. Then for the methods, we use the LDA method with these specifications that is mentioned here. And then also I have to mention that for each of these methods, the topic modeling, so we produced the topic models with different n-gram ranges, as well as different number of topics. So several topic models were created. And then we had the non-negative matrix factorization as well, again, for different n-gram ranges and for different number of topics they were created. And also we had the contextualized neural topic model with 2 distinct models of combined TM and zero shot. So as we produced a lot of topic models, then we thought a good idea would be to develop a pipeline or a method that can choose between these models and just present that what is the best model. So what we did, we created this model selection algorithm, so topic model selection, that it chooses automatically what is the best performing topic model. And how it works is that it first creates the topics and then find the corresponding documents. Then actually the number of corresponding documents can be chosen also in this algorithm as well. So here in this example, let's say that we have three top documents that is chosen for each topic. Then so the way that the model selection works is that it calculates the similarity between these documents and the topic for each topic and the corresponding documents. So we find the similarity, and this will be averaged over all the top docs and topics in that model. So then we just keep the record of the similarity, and the higher the model with the highest similarity metric will be chosen as the best performing model. It means that the topic model performs well because the topics kind of like, and the corresponding documents that's chosen through the model are very kind of like correlated or similar in a quantitative matter. So let's say that we created different models, topic models here with different n-gram ranges. And so this plot is showing that different similarity index that is recorded for each model. And as we can see here, we can report that model 6 with n-gram range of 2 and 4 is giving us the best performance. And then this method is also quantitatively backed by RAND index as well. So we did try for all these kind of models, we did try to report the RAND index as well. And then as well as this RAND index, experiment correlation as well. So when overall we had different models and then we had different evaluations. So we also plotted the experiment correlation as well. So then these quantitative evaluation kind of like backed our research as well, that our model selection procedure and algorithm is working pretty well. Also, as well as this, we had the qualitative rating as well. And for the qualitative rating, we came up with the idea that for each topic, then we look at the document, again, the corresponding documents. Here in this example, we looked at 5 top corresponding documents. And so if the document and the topic are correlated, are relevant, it just shows to be like a relevant pair, then we would say that we would rate it as a qualitative rating. We would rate it as 1. And then if they're irrelevant pair, then we would rate it as 0. And then if it is a non-topic or the document is vague, we would just rate it as -1. And we can see here that we chose the model and qualitatively rated that, and the average qualitative rated by like 80%, which is pretty good. So here we are looking at the results for those the alt-tech channels that we looked at. And it was the main purpose of this research to look at the topic models of the alt-tech platform. And we have the average document topic similarity, and also we looked at the average qualitative rating as well. So we can see that the model is actually performing pretty well for both of these channels, especially for the first one that has like shorter length of documents, and the second one it had huge length of documents. So we proposed that for future work, maybe just so we break down the corpus into several corpus, and then like several smaller corpuses, and then we looked at the document topic similarity. Also, so here's kind of like a conclusion of the work. So we did the topic model selection, we had the quantitative qualitative analysis on that. So we had the document topic similarity, and then we had the random index. We had the Spearman correlation coefficient between this DTS and RI. And it worked pretty well on our unlabeled data set as well, as we can see with the qualitative rating, average qualitative rating, especially for the smaller corpus. And the model selection chose the n-gram range of 4,4 to be extracted from this corpus. So yeah, and I've already talked about the future work as well. So I think that's it for now, and thank you for your attention. If you have any questions.